Good afternoon.
Good afternoon. How are you?
I'm good, sir. How are you?
Fine here again. So, how's going on your life and your work at Denmark University?
Yeah, it's quite good. Super busy period because exam just
It's
finished and
after a very long time to see you.
yeah, almost 7 8 years. It's quite long.
So, I request Mr. Agam, who is hosting this FDP. So, I request Mr. Agam to introduce our esteemed speaker, Dr. Gaurav Chaudhary, so that we can continue forward.
Okay, so thanks for this. So I'll be giving brief description of who Dr. Gaurav is. So Dr. Gaurav Chaudhary is an associate professor at the section for cybersecurity engineering, Department of Applied Mathematics and CS, Technical University of Denmark. Previously, he worked as an assistant professor at the Center for Industrial Software, the Max McKinley Moller Institute, University of Southern Denmark, Sonderburg. He received a PhD in Information Security Engineering from Sunchunyang University, South Korea. He has worked on various projects funded by reputed organizations such as the European Research Funding, Horizon Europe, Industrials Fund, National Cluster Digital Technologies and Innovation, Digital Lead, Institute for Information and Communication Technology Promotion, National Research Foundation of Korea, and the Air Force Office of Scientific Research, USA. His research interests include threat intelligence, IoT and CPS security, cyber security, vulnerability assessment, 5G security, and drone security. He has authored and co-authored 80 plus peer-reviewed scientific papers in international journals and conference proceedings. He also serves as a reviewer for various IEEE, ACM, and other journals. So, handing over to Sir for further proceedings.
Yeah, thank you so much for introductions. So let's begin today's talk. So can you see my screen?
Yes, it's completely visible and clearly audible.
Okay, perfect. Let's go. Good afternoon, everyone, and esteemed speakers and listeners and organizer. I would like to give first of all thank you to everyone who is joining these sessions and also like Dr. Jitendra Goyal to give me this opportunity to speak about today's topic. So, in this talk today, we will discuss more about cyber physical systems and how it's growing day by day and how it will take place in the security modules, what are the requirement, and what kind of research we can do in the further investigations of the cyber physical systems. So as you can see, this is the outline of today's 2 hour talk. We first half we will discuss about the basic cyber physical systems and what are the overview or what's going on in the current state. Then we will talk about the modern cyber physical systems like current applications. And today's theme is more on the cyber physical systems in the healthcare. Then we also talk about the what kind of revolutions is going on in industry 4.0, industry 5.0. Then what kind of like a particular challenges in terms of a development, in terms of companies, in terms of research. Then we talk about little bit more about the future works as a student, as a researcher, what you can do in the future. Then some kind of intersections about the IoT and cyber physical systems, how they are quite different to each other, how they have a similarities. Then we will move into the more significant requirement as a cyber physical systems, because now you can see that machine learning algorithms and AI, they are like a core part of our cyber physical systems and IoTs and other research domains. So once the automated systems came, so more security concerns will also associated with that. Then we talk about the recent attack which happened in the recent years, what kind of advanced solutions we are developing. So one of the case studies with the patient, like a PCA, patient control anesthesia, like which is also automatically controlled. Then some kind of ongoing European project in which we are working, and what kind of future works can we can do further, like while studying in these topics. So this is my intro, which is already given by the organizer. So I'm working as an associate professor in DTU Denmark. This is the like IIT of Denmark, and I usually work with the misbehave detections, IoT and cyber physical systems. And my research application areas like Industry 4.0, smart homes, IoTs, OTs, and mostly on robotics. Currently, I'm working with the drones also. And I have an ongoing project from funding from the various research organizations. Currently, I have a funding about the cyber safe robotics and battery management systems, and I have previously worked with the big project about the transit and rule based specification based intrusion detection systems or that kind of thing. If you are interested to collaborate, you can reach me through my email. You are most welcome to collaborations and research activities. So let's start about today's topic. What is cyber physical systems? Okay, so you have listened this term many times in your life. So when we talk about the cyber physical systems, it's basically came from the Greek adjective is cybernetics, which mean you have a govern or you have a skill to steering to control some things. Okay, so in 19th century, we are talking about the cyber systems. They are the controller which was implemented as a mechanical, either hydraulic or pneumatic systems, like which is not controlled directly by the any automatic systems, or not controlled by the a human in the loop. Okay. But these are the mostly in the mechanical forms, not in the in the command and instructions from the like a Wi-Fi or something like that. In 20th century, they have started changing their patterns, like electro controls and electric controls usually came in the market. Now we are working in the cyber systems where your actuator sensors, they are placed in the particular area, like in the hospital, in the industries, and then there is a communication network, maybe LAN, maybe Wi-Fi, and another LoRaWAN. There are plenty of communication networks. Then we have a distributed controllers, and human always play with the distributed controller to control actual implemented systems. Okay, so this is the overall posture of a cyber physical systems. What are the cyber physical systems? If you talk about the definition perspective, so these are the physical and engineered systems whose operations are monitored, coordinated, and controlled and integrated by a computing and communication core. Just pay attention on the terminologies, operations are monitored because we always look into what's going on. You can see the data and you can see the logs. Coordinated because many systems are associated with the single task. Like if you put something, some changes, like a doctor want to put some kind of injections or some kind of medicines in the completely coordinated healthcare systems, then he can look what are the pulse rate and what kind of a body parameters and everything. And it's particularly controlled and integrated by a computing and communications code, because the instructions whatever we have given to the systems is controlled by the some kind of a machineries, and there will be a backend support from the network side also. So you can see this is the a particular a cyber physical system integrate computing, communications, stories, capabilities is the monitoring or control of entities in the physical world. So as you can see that this system has offering computing, communications, and storing capabilities. So lot of a research domain will open into each parameter. Like if we talk about the computing, then we need a lot of fast computing, fast processing systems. We need a optimized algorithms. We need a fast codings and everything. If you talk about the communications, now communications is also an open paradigm. So we are talk about lot of things about the networks, how it should be operated, what kind of communication speed is required, how fast the data should go to the receiver and end users, and how you can ensure that it should be end-to-end encrypted. It should hold the integrity, and it also hold the a confidentiality. So whatever the instructions you have given to the particular device, it should not be changed. Okay. So from now nano world to large scale, with areas of systems, we are deploying a lot of cyber physical systems. So this is the convergence of computation, communications, and control. So it's covered a lot of wider areas. If we talk about the recent applications, so look at your near systems, you can see the lot of like semi cyber physical systems or fully autonomous cyber physical systems are the part of your life. So recently we talk about the smart traffic controls. Then there are multiple cameras installed, drones are installed, and then we have a lot of like a processing unit in the back end. So we are controlling, we are processing even some kind of a machine learning algorithm for the face detections, and a lot of things are going on. Okay, the second applications, you can see the smart automobiles. Recently, if you talk about the Tesla, or if you talk about the upcoming cars which are focusing on the auto cruise and semi guided devices in the automobile industry. So plenty of research on the cyber physical systems on the ESU side, and particularly battery management systems, and how you can go vehicle to infrastructure, and infrastructure to infrastructure, and vehicle to everything like a V2X. So that kind of technologies are still in the research domain for the cyber physical systems in automobile industries. Now we talk about the smart transportation systems like surveillance, communications, and these things. If you talk about the ships, large cargo ships, if you talk about the aviation sector, okay, so they are also a smart smart organizing like systems which are the part of cyber physical systems. Now the more important, because this talk is more focused on the healthcare system. So you can see that now in upcoming time, a patient will be fully monitored, fully fully in the safe secure mode. When we admit into hospital, that will be monitored by the fully controlled cyber physical systems. Even the medicines, even the healthcare particular devices which is installed in the smart hospitals. Then even your medicines which can be like in the western world, where is we are lacking with the human resources, we can use the mobile robots or mobility robots which can use the carry the trays, medicines, and these things. And the whole ecosystem is controlled with the with the some kind of communication networks, and there are different segments like a particular body sensor actuators, then the different kind of computing devices, then also monitor with the some kind of a doctor. And there are different kind of stakeholder devices, like even your bed which is equipped, which is continuously sensing your body temperature and everything. So that kind of applications are the core application for the cyber physical systems in the healthcare. And we also have seen the industry 4.0 and industry 5.0 in the recent trend. So this is the when human is not the key parameter or key operator in the industry. We talk about the supply chain. So a lot of a motion robots you have seen, they are putting some nut bolts and these things. They are continuously moving. So these ecosystems is also part of cyber physical system, because just assume that you can see in the diagrams, human is just observing some things. There are plenty of communications through Wi-Fi's and these things. There are multiple mobile robots which are putting lot of assembly lines. So you can see that in these big organizations, only few employees or few humans can control the whole big industry, and the efficiency and the processing and computation speed of industry 4.0 is much more higher than the previous, like when we talk about when we have a human oriented development in the factories and these things. And recent, we are too much fancy about our lifestyles, so we are focusing on the lot of smart home applications, your fully controlled devices like a TV, your ecosystems, temperatures, your light, and everything. So everything you can control from even your office. You can look what's going on. So a lot of things which are the part of cyber physical systems, like a sensors, like a particular like a theft sensors or fire sensors, or some kind of a healthcare sensors also. And also you can also include some kind of applications like a camera, and some kind of noise reductions and these kind of things also. Then the recent application is smart grid. Like I talk about the power generations from the some kind of solars, or it doesn't mean the solar. There will be also like a physical like energy generations from the water, from the nuclear, some things like that. Then there is a distributions to the city, to the normal users, end users. So then the smart meter. So from its energy generation to distributions, it will also serve as the same as a cyber physical systems. Okay, so there are some kind of a physical components, some are placed as a sensor and these things, and the distribution will take place in this manner. So now you can understand this is the biggest theme of cyber physical systems. But when we talk about the cyber physical systems, how it is different from the embedded systems, because in the older terms we talk a lot of about the operating systems, then we talk about the embedded systems. Now the new terms came as a cyber physical systems. Then, but how it is different? So usually embedded systems, they are the integration of information processing into product. So there will be more important things, the time and concurrency. So when embedded systems plus physical environment will meet, then it will mold into a cyber physical systems. So cyber physical systems usually are the orchestrations of computational resources with the physical systems and environment. In embedded systems, like you have a washing machines or you have a small systems, okay, which has a all computing capacities are installed over the device. Okay, so that kind of difference you can see. So embedded like a systems devices having information processing systems embedded into them. Okay, so that's a small part, typically confined into a single device, limited resources. We don't have a much powerful computational resources. Main issues are real-time response and reliability, because when you want to work with too much critical applications, then it's quite difficult to go for embedded systems. So then when we want to go for more computational efficiency and computational capabilities, then cyber physical systems are the core component. So like complete systems having physical component and softwares, they are network set of embedded systems, multiple and distributed resources are shared. And no, we don't have a much resource oriented problems like a deadlock and resource constraint, starvation, and these things. So here is the main issue is the timing and concurrency. Okay, so when you want to work with the cyber physical systems, these are the open problem. Still, you always go for the timing and concurrency issues, because when you want to give a like a commands and some things, there will be a synchronization, and there's this kind of a pattern is it's shown in many applications. So once we move from the big cyber physical systems, then recently a mobile cyber physical systems also in current era. So mobile is a little is the smallest version of biggest cyber physical systems, but holding the same capacities and same attribute and same functionalities as like a big cyber physical systems. So usually in application areas of mobile cyber physical systems cover virtually all society, like a social important application sector, which can you can see the consumer applications like a mobile computing, communication, localizations, navigations, gaming, entertainment, fashions. Okay, so these are the like a small applications like a watches, like a fancy, like a cloth, which is also have a sensors, like a, your health, body health devices. If you want to go for like a VFX, some kind of entertainment also, like when you can see the live holograms and these things. Then extensions or replacement of human capabilities like teleoperations, personal assistants, artificial limbs implements. Okay, where you don't want to put your energy to operate something, so that kind of like a small operations, and they can also be done by the mobile CPS. Then another applications are social systems like a smart healthcare, and another numerous healthcare applications, assisted living, law enforcement, public safety, military. Okay, there are a lot of like applications still in the like a drones also that can consider as a cyber physical systems, robots, okay, military vehicles, and smart ambulance systems. They are also part of a social systems. Then transportations and automotive like a traffic control, navigation, tracking, communications, they are also important stakeholder for the CPS. And some of also you can talk about the industrial safety, security, and military applications like a real time in the field surveillance, monitoring, small missile systems, drone detections, like a some kind of a device inspections, repair, robotics, instructions assistance. So there are plenty of things which can also paying a lot of significant contributions in the industry as well as in the our military applications and the smart future oriented things. Then the commercial applications like a mobile inventory tracking, consumers like a geotagging, wearable augmented realities, other systems of touristic applications, and many more. Okay, so as you can see that now we are growing day by day, and dependency has been increased on these applications. So the economical and social importance of mobile CPS is very high and rapidly increasing. So when you can see the recent rapid developments, so systems on a chip technologies, we started from 1994 to 1999 at the time the RFID takes and best solutions in the market. Early 2000 we are more focused on the WSNs oriented distributed communication technologies, smart meter and these things. Mid 2000s we talk about the smart devices little bit, like a web enabled and app services and these things. Okay, now talk about the 2020, then cyber physical systems, social systems like a link data, semantics and these things also play a important role. Then we learn that how we can work with the coordinated device and these things. In 2022 you can see that there are a lot of distributed applications like a cloud, big data, like a mature IoT applications and a lot of things also. And now if to talk about the in 2025, lot of like a smart intelligence about the AI, machine learnings, augmented like a reality based, so like a lot of applications where the human interface is very low, and your system is learning on the basis of available available patterns, available data, available data sets. Okay, so whatever the things you are feeding to the machines, or on the basis of they can be learned and they can process, they can work together in a coordinated manner. So as you can see that human life make a lot of easy distributions among in kind of in such kind of applications. So this is created a large discrepancy between what is possible and what is used nowadays. So that's because we are talking a lot about things that we are growing, we are doing very good in research. So we will grow in every sectors, but what can be adapted, how is it ethical, what are the significant challenges also coming with that. Okay, so this discrepancy bring like a cause both a very strong technological push and market pull to create new or modified product and services. Okay, so just assume that whatever phone you have purchased in 5 years ago, so you don't want to use that. Okay, so this is the basic example from your lifestyle. So you want to update yourself with the higher technology, higher power processing, higher computational efficiency, higher like a computational capabilities, and you want to go for more like a smallest versions, lightweight versions with the more powerful computational capabilities. Like if you talk about the previous applications of a mobile, then now there's a plenty of like applications are very lightweight but they have a higher computational things. So this bring the results in the our need like a CPS revolutions. Okay, so you can see these are the some kind of statics in the previous years how it has been grown. So if you talk about 2015 to 2025, so we started from 89 to 2 million cars. Okay, but at the time they are only basic functionalities. When you talk about in 2025 how much like a partial autonomy is, these are the partial autonomy is like a, when you have a multiple functions in the cars which can control automatically. Okay, like air pressures, like your automatic temperature control systems, and even cruise systems, and even some kind of issue controls. Okay, and some kind of like a speed limits and these things, and also like on the basis of camera sensors, how your live or real time computations will go in algorithms with your cars also. So still now like EU regulations and US regulations and Asian regulations are not allowing a fully automated cars, but we can assume in the upcoming years that can be also possible, because South Korea and some kind of countries, they are also testing the fleet autonomy like connected cars. But it is it also come with a certain challenges, and like Asian countries are still not open to adapt such cars due to a lot of law and regulations about the responsibilities of traffic issues and all. So now we are on the fourth generations where we are talking about the cyber physical systems. The older when we talk about the mechanizations, okay, stream power and these things. Second generations about the mass productions, assembly line. Third only like a computer and automations. Now we have a smart like a control, coordinated and multifunctional systems. Recently we talk about the IC because IC is also using in the lot of like a sectors like a cell phones, standards and everything. So it's also growing a lot in the last few years. So we have seen that how cyber physical systems and like it growing in our daily life and how research and the market is also growing. So let's talk about the how it's different from the traditional control systems and how it a new cyber physical system is known as. So as we discussed the previous slides, focusing mentioning about that in the older time we have a mechanical or hydraulically controlled systems, like there is a controller, there is a plant, okay, and you will continuously giving the instructions on the physical mode, then plant or whatever the machine will operate it on that. In the recent terms, the controller will change with the cyber, so you can also control with the cyber world, like you have a like your systems and outside of factory or maybe in the some certain areas, okay, and plant will be the physicals like some kind of a windmills, some kind of a solar plants and everything, okay, there are multiple positions, okay. In that period you can see that there are a multiple like in both like a two segment we have a lot of things like a sensor aggregators, and we have also like a PLCs, okay, and your distributed control systems here is and they are connected with the cyber worlds, and the control signals on the basis of computational things the actuator can perform something. So these are the some kind of a closed loop solutions. So in between that, like when we talk about like a controller and plant, so a lot of it's not only like a two unit. So there is a particular layered communications. Usually we have seen the OSI model, TCP/IP models. So there are particularly a particularly layered architecture is there when we divide into layers. So CPS layer is also divided into three major layers. Mostly is perceptions, transmissions, and application layer. So perception is like your data and information collections. So actual devices like sensors, aggregator, like actuators, and RFID tags, GPS. Okay, so these kind of equipment which are processing for the data and informations, they are placed in the some kind of a low level attributes. Okay, then the transmission is responsible to carry these information which is gathered by the sensor or aggregator or these things. So there are plenty of mediums. Either you can store on the cloud, either you can use the internet access point, Wi-Fi router, switches, Zigbee, LoRaWAN, 5G communications also. Okay, so there are the particularly a lot of methods are there to collect and to send data for further processing. Okay, so data and information transmissions. Then the third layer is mostly on applications, like where we usually process and take the decision on the basis of some data, whatever we are receiving from the factory or from the like a particular smart care applications like a healthcare. Okay, and on the basis of we make a decisions, and on these decisions will implement on the basis of some another loop of like a transmission layer to perceptions layer, which is reducing the speed or increasing the speed, whatever the things we have to do, we usually do like that. Then from layer, like we started from the generalization approach to the specialization approach. We talk about the cyber physical systems, what are the cyber physical systems, what are the applications. Now we talk about the particular layers. Now let's go to the how uh, kind of attributes a cyber physical system should carry. Okay, so when you talk about the cyber physical systems, so we usually look for basic fundamental requirement in a cyber physical systems. So basically it should be a reactive. What it mean, like when I should give a command or an instruction, it should be performed based on the instructions in the environment. Okay, so reactive system is one of which is in the continued interaction with this environment and execute at a pace determined by the environment. Just assume that if I have a sensor to control the temperature. Okay, I have a smart factory in which I am controlling temperature because I'm storing some medicines or these things which should not be go beyond 15 degree. So whenever there is some kind of a temperature goes down, so my machines, my cyber physical systems, on the basis of sensor, they continuously compute, and on the basis of feedback they give that reduce the air condition temperature from 15 to 14, so it will be consistent. So it should be reactive whenever the instructions came from the computational entity or from the machines or human, so it should be have to perform on the basis of whatever the command have been given. Then hybrid systems are like mostly like they have an analog plus digital part boards. Then it should have a dedicated, because when we design some kind of a cyber physical systems, like when we talk about automobile industries, when you talk about the healthcare, it should be have a dedicated for the particular applications. Okay, it should be have to familiar with the behavior. Okay, so what kind of attribute has been designed and coded, like just assume that I have designed a cyber physical systems and we are deploy for the hospitals. Okay, smart hospitals, so they have to familiar with the like a lot of like a hospital oriented things, and they have to be dedicated for that. Okay, so whatever the resources which are not fully meeting the requirement of a hospital, then we can remove. Okay, so just assume that a industry 4.0 or something requirement basis on the some another applications, these are no useful, then it should be removed. Okay, so that's why we have to consider it as a dedicated applications. The last characteristic is the dynamics. Okay, so whatever the frequent changes of environment, okay, we have to update our systems on the basis of these things. So these are the some kind of defining characteristics, like a cyber physical coupling driven by the new demands and applications, because day by day, as you can see in 2022 and 23 21, we have a different requirement. Just assume that we came with the new terms as like a coronavirus, later the new like a war oriented situations also going in the market. Now machine learning and AI and LLM models are like they are placed in this requirement, blockchain oriented solutions. And now we are talking about the post quantum. So a lot of things are changing. Okay, so which bring the new demand. So cyber capabilities in every physical components also. So that can be a process mode, large scale wired and wireless networking, and network at a multiple and extreme scales. So it should not be like a lose the availability when we work with a lot of like a larger data. And then we can also focus on the systems of systems, like a multiple systems, cyber physical systems you can make to process or to work for a dedicated task. So new spatial temporal constraints also came with that, complex at the multiple temporal and spatial scales, dynamic and recognizing reconfigurations, these kind of things also we have to consider. Then novel interactions between communication, computing, and control. Okay, so when we talk about between interconnections between whole loop, it should be also secure. Okay, so and also robust, and also like it should be processed very fast, very speed oriented, and in terms of real times also. So high degree of automations, control loop must close all at all scales, large number of non-technical heavy users in the control loops. These are the some certain challenges when we talk about these applications. So these are the open research areas where we are looking continuously. So let's take the one of the concrete examples, like a healthcare and medicines. Okay, so just assume that this is the patient, like a patient which has some particular sensors, like a pacemakers, and a lot of sensor displays on the monitoring of a patient. These like information is carrying with the sensor and forwarded through some kind of access points. Okay, which go to the data servers. Okay, there are some kind of data holding like a capabilities. Maybe there will be also possibilities to process these data, everything, whatever the algorithm you will make, it depend on that. It can also send like some kind of a particular some kind of a doctors, because doctor usually consult on the basis of the information whatever we have received. So now assume that on the basis of current requirement in current world, we will go to doctor, then we go physically like a need some reports like a blood reports, everything, then we carry the physical report to the doctor for the consultations and consultancy. But in this like fully automated systems, like your body, like when you admit into hospitals, so all like details regarding your blood pressure, weight, like temperatures, like CT scans and everything, they will directly upload it to the centralized systems. Okay, there will be some kind of analytics, and the directly the doctor can access through his laptop or his mobile or some things. Okay, and some kind of a medical request is also can be stored by the medical service providers. Okay, so they can process for the medicines and these things. Okay, so this is the fully automated and semi-automated systems, which is the like these are the like upcoming systems which we are implementing in the higher point or maybe advanced hospitals also. So this is like a national health information network and electronic patient record initiative. So you can record for each and everything. So okay, so medical records at any point of service, like whenever you admit, so you can check if you have a previous some kind of a symptoms or previous disease or some things before processing something, because doctor have to look more. Then some kind of a home care like monitoring and control. So everything is like your pulse oximeters, your like if you have some kind of glucose devices or some kind of continuously monitoring about the oxygens, glucose accelerometers. Okay, so there are a lot of things, a lot of sensors you can place over the body. Then operating rooms for the future, like a closed loop monitoring and control, multiple treatment stations, plug and play devices, like robotic microsurgeries also. Okay, so a lot of things like in the smart rooms where the human is not like usually placed. So doctor can fully control the robotic surgeries and through the particular closed loop communications. Then progress in bioinformatics, gene protein expression, system biology, these things also is going on. So if they want to work for the some kind of sampling and these things. Okay, so this is the one of the examples. So you can also found the some particular paper like a blockchain based framework for security and privacy assured internet of IOM things for the effective access controls. So this is a good paper. So if you are interested, you can read. Then when we talk about the biggest cyber physical systems, we have moved to the small, like modern cyber physical systems, like smart wearables. Okay, so they sometimes they also considered as a IoT devices, but with the computational capability, they become as a small cyber physical systems, like a smart band, smart watches, okay, smart sunglasses. Okay, so these are the some kind of examples you are seeing into your day-to-day life. Okay, so what they do, they collect, because they have some kind of a sensors, okay, system on the chip, some sensors, they continuously monitor your health through whenever you wear these kind of things, they continuously monitor, and they are connected with some kind of a internet or some kind of a processing capability unit, which process and giving the, okay, you have a more heartbeat, you have a higher pulse rate, you have how many kilometers you have run, what are the things. Okay, so whatever the mechanism you have defined with particular device, it can be shown, it can be computed with the device. Okay, now let's talk about bigger cyber physical systems like aviation sectors, like energy sectors, like smart hospitals, like a biggest entities. Then we came with the mobile cyber physical system, like a small. Then let's see how it can be a smallest, like when talk about the pacemakers. Okay, so that kind of things also considered, because they have some kind of a sensing capability. They, on the basis of sensing capability, they do computations and they do process. Okay, so whenever your pulse is go down, so how it will like a pacemaker increase. Okay, because it's have a continuously processing of that. Okay, and like a PCS devices also, when you someone has a insulin controlled some kind of devices when they wear, so when they continuously monitoring the health, whenever they look that there is a some kind of a deficiency of some things, they immediately release the sugar level and these things also. Okay, so these are the smallest applications also. So now we started from the large applications and we reach to our micro or like a mini oriented cyber physical systems also, which is the part of our day-to-day life. That's why let's bring a grand like a direction for the researcher communities and everyone. So just assume that if we look into the upcoming industry sectors, okay, so like from the technical perspective, from operational perspective, from organizational perspective, how we are looking for near to zero automated traffic, okay, where like you don't have to see the policeman who is continuously holding some kind of a plate and stopping peoples and making a traffic like a more coordinated. Instead of we have some kind of a systems like a fully controlled, or they can also divert the traffic and these things. So blackout free electricity generations and distributions, especially in Asian countries, in our countries, like we are a lot of dependent about the on the like a rain oriented season. So when such kind of things, natural climate issues came, so we usually feel the less electricity in rural areas and these things. So that kind of thing can also be a challenge. So these are also in the big pictures we are looking for that in the cyber physical systems. Then perceptual life assistance for busy, older, or disabled people, because we are also seeing that the world is be quite busy in their job offices and these things. So we need some kind of a system which can take care of our older parents and older peoples. Okay, so then we also looking on the smart agricultures. Okay, so now you don't have to go as a farmer everyday farm, look for the some kind of disease on the also check the water level of crops or everything. So that also can be installed and controlled by the big cyber physical systems. Then energy aware buildings, okay, smart buildings and everything, which are focusing on the like a fire content alarms, temperature control things, smart locks, smart doors and these things. Okay, then location independent access to the world class medicines. So that can also be like on the basis of your disease. So the centralized data will be accessible by the any doctor through his particular private keys. Then he can have a look into your disease and provide immediate medicine. So there is no location dependencies. Like if you're traveling from one city to another city or another country, so your data can be accessed at the any point of instance. Then self-correcting and self-certifying cyber physical systems, one of applications. Okay, so when we talk about the cyber physical system, there are multiple components. Okay, multiple processing unit and these things. So if it will goes one down or some things, how the load should be distributed. Okay, and how these things will carry forward on the basis of these things. So these fall under into the self correcting and self-certifying cyber-physical systems. Then one of them also another things is reduced testing and integration times and cost of complex cyber-physical systems. Because when you make it cheaper, it will be accessible. So cheaper is not is like that you are not testing fully, but the testing and integration mechanism should be very faster. We can deploy some machine learning algorithm which are continuously testing some kind of a particular part and passing through the not going for the manual testings. These are the demands we are talking about that. So now if you talk about the key trends in the systems, so these are the key trends, like a system complexities we are looking to reduce, like increasing functionalities, increasing integrations and networking operabilities, then growing importance and resilience on the software, increasing number of non-functional constraints. Okay, due to like a demand, so system complexity is also increasing, because when you want to increase the functionalities as much as functionalities, we will go for coding more much and more. Then there are a lot of a non-functional constraints also came, you are using a lot of things which are not using in the particular dedicated applications. The nature of tomorrow's systems, it's a dynamic, because we don't know that what is the need for today. It should be the same as for the next upcoming 2 years. It's not like that. So when we talk about the dedicated application, it should be have to be adapt dynamic features or dynamic adaptabilities. Because dynamic, whenever that some changes will come, your machines, your cyber physical systems, they have to be in the changing nature. So you can be update, you can be upgrade, you can be recode. Okay, so that kind of things we have also look for the self-aware, self-adapting, repairing, sustainability. These kind of things we also look into the key research trends for the cyber physical system. So CPS systems everywhere used by the everyone for everything. Okay, now you see that this is the this is the super fancy coin terms, like everywhere, used by everyone or for everything. So you can deploy for the particular dedicated applications. So when you talk about such application, then a higher expectations usually came out, like 24 by 7, like a 7 day of a week usually run for 24 hours. 100% availability. When you need some things, it should be available. Reliability is 100%. Connectivity should be like instantaneous response. It should not be delays. It should not have a latency. Okay. Then the class is every kind of persons. Like when you talk about a small kid who is just got born, who is also accessing such a facilities. Then talk about the older people's, middles, disabled, rich, poor. Every kind of a class is the key like using persons for the your applications. Then numbers can be like individual persons at the smart home, many persons for the smart classrooms, larger like a groups as like a social networks, cultural populations. Okay. So if such kind of a large populations and different heterogeneous requirement came, so which motivate us to work for a dedicated systems which should fulfill these requirements. These are the like a basic things about the cyber physical systems. We talk in the last 30 minutes about what is the cyber physical systems, what are the current applications, okay, what are the features, what are the characteristics, what are the mobile cyber physical systems, how we are looking a big picture of a cyber physical systems. Let's talk about the things evaluations, okay, because when we talk about the cyber physical system, they are the larger systems, but when we talk about the IoT, they have the small internet of thing capabilities, which has a only like a data gathering and collecting and sending capabilities. Okay. So from like a RFID to robotic things and autonomous vehicles, we move into different worlds. Like we are looking for the connected, autonomous, embedded everywhere having. Then we focus on the pervasive sensing, then actuating, then embedded into edge levels. Then we have a particular like edge level, then we have a cloud level where we can process and we get a lot of things to do changes. And we have a lot of applications like a consumer business and industrial applications also. So these things has been evolved. Okay. The older times we have a single users, now we have a multiple users, multiple processing unit, multiple stakeholders, and multiple the accessibility is also enhanced. So this is the ecosystems, like how IoT has been evolved out from 1950 to 2010, 2030, how we are looking. Okay, just assume that wired network applications in the older times, when we are small kids, we are using more LAN cables oriented internet and these things, and lot of limitations with the computational capabilities and the connectivities. Okay, now recently in 2010, 2008, around the IoT term has been coined out. So cloud-based IoT platforms, centralized security solutions, and a lot of things also. In 2020, most human-centered IoT and autonomous network intelligence IoT is also placed out for the distributed heterogeneous architectures, federated and dedicated like platforms, and distributed laser technology integrations, and particular security applications also. And in upcoming time, we are talking about the blockchain features also can be integrated with the IoTs. Okay, so using IoT technology from bridging human and AI to amplify human performance and deliver breakthrough to refresh or reshapes human lives. Okay, so what motivating us, like a from a thorough applications to a AI driven applications, we are continuously changing the requirements. Okay, so which bring the industrial requirement also at a high level, which also bring the researchers like a requirement, because researcher is also working on the basis of a human and industrial requirement on the research perspective. So these requirements are continuously facilitating add-ons, so it's also quite difficult to reach on that level where we are demanding and supplying whatever the need of a market. So as you can see that this is the research trend, you can see on the graph, like when we talk about the market, like 5 billion people, I mean 50 billion more than smart gadgets, smart things are already in the market. So in the sensor, in the device network management, communication protocols, and in some gateways, in some kind of actuators, database servers, particular routers, and these things. So there are a lot of things where we are using IoTs and these things. So this is the revolution for the particular IoT, and it can be seen in the connectivity modules like that. In every day-to-day life, you can see somewhere somehow the connectivity of IoTs. This is the like applications. When we talk about the communications paradigms, we can use some kind of LTE, cellular 4G, 5G. All the time we are using 2G GSMs and edge device CDMA, particularly like 1G also. Only LoRaWAN assisted solutions also, like a Bluetooth and these things. Okay, so they can be also for low modal communications. Then you can place, they can be collected for the all the body or maybe in the network for the particular dedicated applications, like a, and they can use also for the main WAN, LAN, PAN. So there are plenty of applications. So this is the cyber world where you are collecting the informations or data for the further processing. So these are the applications which are looking for the connectivity of such applications. Now let's look how is IoT and cyber physical system is different from each other. So if you look into the pie diagrams, like a wireless sensors network and cyber physical systems and IoT, they are quite contradict to each other in some manner. So they are sharing some kind of a part, like just assume that like some attribute of wireless sensor network, some attribute of IoT, they also fall under into CPS. So IoT and CPS share many core technologies element, like some sensors, like something, some like a programmable device and some things. But how it will be different, because CPS is always in the closed loop. Okay, so they have a computational like a processing capabilities on the basis of a control, and cyber and physical will show the control loop. But in IoT, you only gather the informations and process and send for the processing for the further on the cloud or maybe another methods. Okay, so it should not follow a particular term to go for computation. Okay, and wireless sensor networks are the forming some kind of a attribute for the connectivities and these things. Okay, so you need some kind of a connectivity for the multiple sensors for sending data and these things. Okay, so you can see in this loop, so core science and technology engineering, they fall under the real-time systems, networking, control, safety, verification, and the security. So we are a lot of like IoT developer we can see in each and every sectors, not on the smart home, like a smart healthcare, industrial IoT, and your day-to-day life is smart like a watches and these things. So that was the oldest data, like a 1400 global developer survey, 40% working on the IoT apps today. Okay, so this is like a really a significant growth in this sector. Okay, so the previous talk and previous like a slide more focus on the what is cyber physical systems, what are the applications, how it's reacting with the world, what are the major applications, what are the basic features. Then we talk about the IoT, how it's growing, and IoT connectivity, because the connectivity is also most important thing, because if you have a computational capabilities in another end, you have to always deliver the data for the computation. Then the more important questions came out in the market is why security. That's the major part, because as you can see in the last few years, we are more dependent and we are more connected in the cyber world. So our day-to-day life started with the internet. Okay, so everything we are sharing, we are processing, we are doing with the internet. But the recent trend in the last few years shows unexpected attacks on the every part of your life, like on the smart grid, on the smart healthcares and aviation sectors and everywhere. Okay, from day to day life, we are affecting with that. So which bring a lot of challenges. You can see that like recently some of attacker, they try to attack on the ICS frameworks. Okay, and then operational disruption for the critical infrastructure. And in 2008 there was a big attack on the Estonia, where they control the whole city power and these things. Then some of try to capture, like this is the example of one of try to capture the like a pacemakers and these things, which is connected with the internet or some things. Someone try to capture your vehicles, autonomous industry also. So every sector is getting day by day a plenty of hacking and a attacking pattern. Okay, so that's a problem. If you will not design your system as much as secure, there will be a chance that you can be cause a security problem. Okay, so this is motivating us, like from, if you talk about the current trends in 2025, so 60% uh, more than like a 60% increase in the previous times whatever we have seen in 2024, so for more interactive intrusions, and 73% in the increase in the second half compared to 2024. It's a huge, like the attacking pattern is going as on the excessive manner. The average breakout time for interactive e-crime intrusion activities decreased from the 80-minute 23 to 60-minute in 2025. So I will explain what is this term. Like just assume that if I want to break a systems, so if I want to enter in your systems, like you are using your computer, if I want to break, so the anatomy is taking 84 minutes to reach through your systems. I will check, I will send a ping request, I will do some kind of social engineering, I will use some kind of a tools from the Linux kernels, like some exploiting tools, or maybe some kind of a bypassing of your firewall and these things. If I will try to enter in your systems, if I want to enter without the password, it was taking 84 minutes in 2020. So that was the fastest, like when you target a unknown systems, that was the, but in 2025 it was become to the 62 minutes is required only to break a system. The fastest observed breakout time was only 2 minutes and 7 seconds. If your system is weak, if you are not following some certain security requirement, then there is a possibility that it can be break within 2 minutes and second. So as like a security teams, there are hacker threat actors also in the market. They work for only money. So you can see that now geopolitics is facing a lot of challenges in few years. So due to that, cyber espionage and cyber attacks has been also increasing. So a lot of like hacking teams and hacking particular groups, they are continuously targeting some kind of a particular government oriented or national, like interest oriented, like a organizations or some kind of a communities and these things. Okay, so maybe a electricity grid, maybe some kind of a website, maybe some kind of a healthcare and these things. In 2020, around 4 years ago, we also got an attack in India is on the AIMS, like hospitals. So our data is also go through a ransomware. So that kind of like a group, they are also targeting such a attack. So these are the well-known groups, like from the Russia, Vietnams, and like from Iran, Pakistan, Georgia, and Colombia. So where these are the well-known hacker groups, they are continuously targeting. So plus 32, and there are less known, but these are the higher end error. So this is the anatomy I was mentioning, that how much time is taking to break a system. So usually we perform every year with the available resources and available tools, that how much time is required to break a systems. So this is anatomy. You can see that if adversary, okay, so if I will use 39 minutes to only access his credentials, like I will try to do what kind of things, I can send you a phishing emails, I can try to look into your social media things, I can try with the machine learning algorithms to generate some of a confidential password. Then I can also perform a brute force attack on the basis of whatever the information I have gathered. So now AI or machine learning can be used to generate a lot of passwords. If you give me a lot of your attribute, I can generate what are the possible passwords. Then we can perform some kind of a brute force. Instead of bypassing the system, it's quite easy to get or guess the credentials, because the bypassing is also quite difficult because we have a Windows firewall and lot of things. Then in 31 second, once you break the systems, you also your like intrusions begin. Then in 31 seconds you can also go to drop the legitimate files, you can delete some things also. Then drop do discovery tools, you can disable some kind of tools which are like it does not require by two-way authentications or biometric authentications to shut down some things. Then some kind of a ransomware you can also deploy. 2 minute 15 seconds discovery tool run is block, so you can also block some kind of a tools. Okay, 4 minute 13 seconds like a open control panel if you want to do some kind of a changes. Okay, so some kind of things you can play in the systems once you enter. So Just assume that this is the like anatomy. If you are really interested into the recent 2024 anatomies, like how the system is going to be break, so you can also look into the particular link. So what we have observed from recent year, like a 71% has been increased, 4.4 millions. We have to also focus onto a important stakeholder about the cybersecurity threats. So these are the some examples. So let's look into the some examples. So this is the one of the example, like when we have found a lot of vulnerabilities, zero-day vulnerabilities in the massive IoT devices. This is known as the Ripple 20. So according to a press release, the series of zero-day vulnerabilities. Okay, so zero-day vulnerabilities is like that some kind of a bugs which is not identified at the time of testings, or until that day they are unknown. Okay, so on the first of day it is coined, which is known as a zero-day vulnerability. So these kind of vulnerabilities has been identified into IoT devices. So that kind of hundreds of million IoT devices in the whole world has been spread out. So this is a big challenge, when you deploy some things. If you want to, if you want to do some things, want to change, it will be quite difficult to update and these things. Then we have also identified some kind of vulnerabilities in the fish tanks, then in some security cameras. So as you can see that, you can believe that these are the not a fancy requirement for a company, but these loopholes can be a entry point for the attacker. Just assume that you bring some kind of a fish tanks in your office. You are working with a big MNC company or something. To due to some kind of a your hobby, you bring a fish tank which is operated and on the smart devices, like you can connect with your phone, you can release the oxygen on the basis of phone. You can also control the feeding seeds and everything, and the your phone is using the internet to connect your fish tanks. But this whole procedure can be a bug for whole like access point of a company. Okay, so you can see this is the like a not a very big requirement there, but this can be a entry point for the attacker. Okay, so these like these things we have identified in everywhere, like a fish tank, security cameras. Now recently like one of the report is also published about the 60% of business in the UK US, like they are also facing about the printer like a data breach issues. Okay, so in this recent world, if your printer has been compromised, so every report, whatever you are scanning, whatever you are printing, it goes to somewhere else. Okay, they are activated in the midnight and releasing the lot of information to the third party solutions. Then multiple report for the security vulnerabilities in smart bulbs. It's like they also place for the fancy things, like you can control from your home and everything, but you connected with the internet. But these are the loophole to enter into your privacy breach also. With these like a security mechanisms, you can see that how a ordinary systems is attacked by the lot of patterns. Okay, so from medical perspective, when you look, so what was the major like attack methods? Like a network scans, we are continuously scanning which ports are open, what IPs are, have a less like a security pattern and these things. Then some kind of a remote code executions, if they are taking some kind of a command and control instructions. Then some 5% attack based on the command injections, buffer overflow, and some kind of other patterns, SQL injections, 0-day. Then 12%, like 33% are on the malwares, like a botnet, trojans, ransomware, worms. Okay, and 26% from the user practices, like a crypto jacking, phishing, passwords. Okay, like you keep low password for your systems, or maybe you open the unknown links. You also entertain some kind of a phishing emails. Okay, so these like practices user practices will participate into 26% of, like, these are the statics, and 41% of exploit. We believe that these are the some kind of a bug systems and these things, but these are the mostly on human errors. Okay, so when you want to reduce, so we always focus on the, instead of like a developing only focusing on a technical development, we also focus on the human training and phishing awareness and that kind of practices also. So what was the issue? Zero to minimum built-in security. Because just assume that in 2010 when IoT came, no one talk about the security. So they develop, they launch the devices into the market, which is already placed in the lot of industry sectors. So this is a challenge. If you want to upgrade, if you want to refine, if you want to deploy some securities, there is no facility or no scope to update these kind of things. Then some kind of a browser interface vulnerability is also in the market. Then some kind of a outdated operating systems. As a human, I'm sure that, just assume that we are the users, we never update our phone until unless we are receiving a particular notification that your phone is going to be update, or you are not unable to run that particular applications, then we usually go for the updating things. So just think about a particular device which is installed in your premises, or in your home, in your company, or in a major stakeholder like SCADA systems and these things. So which is not updated fully, it will also allow some kind of a lot of vulnerabilities and patching issues. Then they are not able to adhere to the security best practices, like what kind of like a frameworks we are deploying, they are not able to cope up with that. So these are the security things we are talking about, that what are the security breaches, how it happening, what are the recent examples we have seen. So the questions came in the conclusive summary, that why CPS security is different from the ordinary as a IT security. So as you can see that IT security is like when some persons are working for your Wi-Fi, for your laptop, for some things. But think about a person's which is a normal IT guys, and your plant, your like a particular control systems are placed in the different locations. Okay, so both control engineer and a security, like a normal IT engineer, has a different roles. Okay, so there will always a issue of sharing resources, coordination and communications among the IT engineer versus the control engineers. Okay, so that's a major challenge. And always there is not a thing that attack can be a failure. Sometimes there will be a passive attacks which always listen about your data, but your system is going everything is smoothly, but they are continuously sensing your data, or they are looking into your data. So normal security guys say that this is not my job, it's a control engineer job. So control engineers say that this is the IT job, this is not my job. So when such kind of circumstances will come, especially like when you deploy some kind of a medical equipment in the hospitals, if it got stuck, then control like a person's also not able to repair them, or maybe they are not able to configure and coordinate it in such a secure manner so it can be efficiently used. So that can be also bring that if a attacker has a partial control of the system, it can derive it into the unsafe states. So that's why you needed a dedicated teams, you need a dedicated security by control systems and these things. Why CPS security is not considered as a safety only? Because security is not only like there will be a failure, or there will be some kind of a hazard nature, or there will be an injury. It should not be like that. So security might be defined in several ways. Like let's stick with the definition. Security is the ability of an entity to protect asset. So in normal life, when we talk about the security, so whatever you have an asset, it's the protection of the asset in the physical mode, in the virtual mode, in the any kind of mode. But when you talk about the computer security, it's also like a ability to and like a particularly protect your asset, like your communication, your data, your control, your device management level, your hardware level, and everything. Okay, you have to protect your whole ecosystem, which include communications, coordinations, monitoring and everything. Embedded system security is nothing else than the previously defined security in the context of embedded systems. So there is no changes on the on the things, and there are many levels. Software security and
एसी उन्होंने रिपेयर करके गए एसी वाले, तो शायद वहाँ कुछ इशू और ऊपर पाइप है ब्लॉक हो गए, ड्रेनेज पाइप जाता है ना, बगल में से जा रहा है।
Okay, so there are glitch. There are many different levels such as software security and hardware security, network security, and many others. Okay, so we are looking into the different segments of the security. There are also non-security aspects which must be considered when speaking about the security, like what kind of the type of network, what kind of communication you are using, what kind of bandwidth, maximum coupling losses, frequency band, downlink and uplink data rates, and the cost. Because when you talk about the security, we need a blueprint. So just assume that if you are building a house, if you don't have an architectural level things, what are the pillars, what are the what are the architectural aspect of a house, it's very difficult to define the security levels. So similarly, when you don't have the knowledge of network, when you don't have a knowledge of your assets, when you don't have knowledge of communication pattern and these things, it's super difficult to define a security aspect over it. Okay, so these are not non-security aspect, but it's also play a significant role in the security. So let's take one of the a pattern, like a attack scenario pattern can be considered. Like if you consider a controller and actuator is placed in the industry, so if you consider what kind of a risk level can be seen. So attack scenarios against the network link between controller and actuator, it's the direct link. So someone is giving a command and it will be reaching to the actuator. So if there will be attack between that, so it's a higher crucial level. Okay, so we have to, because it always break the systems from the actuator to controls. If the attack will be against the sensor, it modifying the values, okay, read by the them or threshold values and settings, it's also considered as a high. Just assume that you place a sensor which is focusing on the fire level. Just assume that you have a lot of sensors in the factory which is giving you reading about the heat level and fire. Suddenly someone attack those sensor and put a default values, and continuously you are receiving the default value as a genuine value. Then you are not able to identify there is a fire or there is some kind of a heat issues. So there is no use. So your hazard level can be increased as a highest. If someone modify the normal settings and supporting the some actuator levels, which is also considered the high level. And some kind of attack can be happen against the administration systems of IoT, some management level, like a complexity, and someone change the password, someone change some things, someone like a distributed load of IoT into and the reconfigurations and network redesigning and these things. If such a thing will happen, there's also considered as a higher crucial levels. If you exploit the protocol vulnerabilities, definitely they can play with all of four these things. If there will be against device injections command into, that's also considered as high. Some kind of stepping stones attacks, they release some kind of like a continuous like a DOS attacks and these things, they can consider as a medium. Powered source and manipulation and exploitations of vulnerabilities in data readings, that's also considered as a medium to high level. If you ransomware, then it's depend on the, if it is on the device level, it's on the data level, should be considered as a higher. So it's up to the person how they are looking the security and the risk levels. Okay, I can define also my risk parameters differently as whatever we are seeing here. So there will be a possibility that the risk parameter will be vary as per the requirement of a organizations or of a particular systems also. So what we have learned, so cybersecurity is the one of the most serious potential risk in the AI-driven cyber physical systems. Why? Because the dependencies on the information systems and network has been increasing day by day. Due to that, when you have a lot of dependencies, there will be risk. Okay, So risk will significantly growing also is a more concern. Then we need a comprehensive approach, like umbrella kind of approach, which will improve the security posture of all ecosystems. Okay, so in which your device levels, your communications level, your deployment levels, and your monitoring level, every kind of levels, and the participant entities will also fall under into the each term will also pass through the some security and security levels, and they also defined with the some security requirements. That's why we need a cultural ecosystems of cybersecurity, which will be implemented with the each sector. Like if you are developing a software, if you are a software engineering, you have to think about the security. If you are a control engineer, you have to think is about the security. If you are talking about the electronics and electrical engineering, definitely go for the hardware component and these things also. So security by design considerations and security by the ecosystems, which will drastically reduce the attack patterns. Okay. So cybersecurity is necessary for IoT and cyber physical systems and these things. That's the bring the most potential requirement nowadays. So how we can incorporate comprehensive approach? Either we can focus on the secure, means like you can establish some kind of a control systems or some kind of solutions which are reducing risk. Like if we are using some kind of systems in the company, you also put some kind of a identity based access control, ID based. Like if you are a manager, if you are a control engineer, if you are a normal employee, if you are a trainee, so everyone has a different kind of a access level. Then your data security, like whatever the data is receiving from the whole organizations or whole like a particular cyber physical system, it should be stored securely, it should be encrypted form. Okay. Then also you can reduce the risk that what kind of if you follow the some kind of a standard and compliances like ISO standards or some kind of a GDPR compliances, or some kind of another standards which are especially designed for to improve the security posture of a companies. Then what is the vigilant? Like you develop the monitoring. Once you define some security protocols, you continuously monitor also. It's not like that you once you define the some securities, then you forget that I don't have to monitor what's going on and everything. So you develop some kind of a monitoring solution which are continuously looking on your system component. Are they working correctly? Are they working not correctly? Okay. So that kind of things fall under into the vigilant. Then resilient. So these two things are fine. Just assume that if attack happen, what we will do? Okay, how you will respond? What are the key steps? Okay, what are the incident response teams? What they will do? So these will things into fall under into the these three terms. Okay, so we when we talking about the secure, resilient, and resilient systems, we always focus that what we can do as a researcher or these things. Okay. So these are the some kind of a security issues we can discuss for the cyber physical systems. So there are some kind of a security issues like
एकदम चले गए कुछ करना होता है तो आता भी नहीं है कुछ ना ही कुछ करता है
I think so someone has a mic issue. Can you please? Okay. Okay, so we are here at the security issues. So when we talk about the IoT and cyber physical system growth, okay, so there are some security issues also we are have identified at the each level. So first issue is lack of secure networking. As we can see that IoT is using a lot of networking, like a connectivity challenges and lot of component about the networking, because they have to share the data. So when you are gather the data, when you send the data, in between there are a lot of communication methods like access controls and some like access points, and a lot of devices is also participate. But we never look into the secure communication networking things while defining such a protocols. So that's a challenge, because when you develop some IoT code for that, if you forget to use some kind of a hashing or some kind of a HMAC protocols or such things, okay, authentication mechanisms and these things, it will create a problem. Anyone can listen to your data, anyone can sense your data and maybe fabricate, modify it, or maybe target your confidentiality, availability, or maybe integrity of your data. So then there are issues is about the lack of confidentialities, like we are not encrypting that, we are not creating a compact um, data encryptions algorithms, we are not adapting. So that's only like without any confidentialities, we are just transferring the data. So there is an issue, like if there is a breach, we are not able to identify, or any unknown or non-genuine user can also listen your data. Lack of integrity is also like you are not putting some kind of a signature with the data. Whenever, just assume that I am a user, suddenly I attack on the power plant and I change the configurations of supply. Suddenly, just assume that I change the configuration of supply. There is no log, or there is no mechanism which is verifying my instructions level. So there is integrity level issues also can be happen. Lack of proper authentications, yeah. So just assume that many applications, I know, I have worked with a lot of companies at the consultancies, so they don't even change the default passwords, even the users. And a lot of I know a lot of persons, they are keeping the same password for many applications. Okay, so there is a lack of proper authentication issues also, like you don't have a proper uh, authentication mechanism, like a biometric authentications or two-way authentication factors, or maybe strong password policies or the password. So whatever the things, these also bring into the security issues. Lack of privacy, because no one is caring about the data and these things. If you have a sensing data, just assume that especially for the medical records, if you release such a data, it will be a use like a loss for a normal like a patient, or from mental level, from personal level, and these things. There's also a major concern, especially for governments. Just assume that if Indian government, or maybe any country government lose his like a his like a public's patients, or maybe normal public's data records. So anyone can lead to the predictions level. Okay, what are the medical situation in any country, and these things also. Then lack of verifications, so that's a major concerns. When we develop some things like IoT devices, protocol, and these things, we are not verifying. Okay, so from verification and validations are the critical issues. The test bed, they are designed for the only KPIs, like if your IoT device or maybe cyber physical system device is dedicated for the particular application, you only test the basic functionalities. So when you integrate, there is also verification is required. When like after mid, there is also verification required that your system is working correctly or not. Then lack of temper resistance hardware. So just assume that if you are developing some cyber physical systems or IoT devices for the military applications, or sensitivity applications, like a drones, or maybe a sensitive drones, or which are going for the some particular dedicated like a missiles and these things. Okay, so there, if you use like some temper resistance hardware, then there will be a possibility that no one can go for a reverse engineering. Whatever the key, whatever the code which you want to make a secure, they can be used. So for the higher like applications, we always keep these these things in our like a requirement, that we put always that we have to use temper resistance hardware, or maybe some hardware constant like applications where the informations and the code is more important, when we don't want to lose such things. Because just assume that there are many drones we deploy in the battlefield. Someone capture a single drone, then it can be communicated with any one of that. It can be down, because the whole communication code can also be shared with the particular device also. So that kind of device can be a spoof device for everything. So we don't want to make that. So that's why we have to use temper resistance hardware also. The most important thing is that lack of security by design features. What are the security design features? Security by design features means like when you are designing as architecture level. Just assume that I have to design a particular IoT device or cyber physical systems. then there will be a possibility that I will consider only particular dedicated applications. Just assume that I have to develop a sensor which only record my health pulse or something like that. So if I did not integrate that, it should be have to be authentication. It should have some kind of a encrypted algorithm which send the data for the cloud. Okay, so if I consider these security requirement as a base by the design level when I'm designing a prototype for the particular applications, then many attacks has been reduced directly. So this is the most important thing for the any applications when we are working with the so lack of security by design features. Then lack of penetration testing. So we are not offering penetration testing because we are not keeping it open. So there will be a possibility that the penetration attack can be done by the attacker which is not performed by your teams. So that there is a that's why we have to always perform some penetration testing before the launching the product. Most important thing is misconfigurations and bad programming. These are the some certain challenges also you have identified into particular applications when we talk about such a issues. Then lack of intrusion detection solutions. You are not deploying some kind of a solution which monitor these things. Then lack of human machine collaborations, because what we are made for, we always think that machine is capable to do everything, so we depend on too much on machines. These things also bring a lot of vulnerabilities. Okay, so these vulnerabilities are the management vulnerabilities, maybe update vulnerabilities, platform vulnerabilities, bad practices. Okay, so due to that, a lot of issues will happen which can be exploited by the hackers. So these are the some kind of a particular threats. You have seen some kind of a competitor, insider, maybe someone leak your data, or incompetent actors, then malicious manufacturers, some kind of a particular terrorist groups, or some kind of a cyber criminals. So these are the some kind of a threat to our organizations, to our products, and to our companies. So with these security flows and security threats and attack vectors, what are the risks? So there will be a security and system flows. So this is a risk that when you are not correctly identifying the code, you are not configuring the proper systems, there will be a possibility that there will be have a flows. So anyone can enter into your systems or maybe into the network. The backdoors, you forget to close the some kind of a ports in the coding. If you are defining a zero, like a buffer overflow situations, and there are a lot of coding issues, bad coding and bad programming concerns, so which keep the open backdoor possibilities also. Remote access, when you are giving without the securities remote access and you are remotely accessing the services from the third party solutions, there will also a possibility that the risk is also high. There will be also risk of device theft. You can lose your particular device, like a drone or some kind of a robots or these things. Then the fake applications on the cloud storage, or maybe Google Cloud, or maybe whatever Apple stores, whatever we are using. So there are plenty of fake applications also there, which is continuously monitoring. You are giving a permissions, they are sensing. So recently, for not for everyone, but those who are not familiar with the such applications, they download a wrong applications, and whole data is continuously going as a phishing to the third parties persons. Then insecure backup and data storage, that's also major concerns. We are not keeping a securities and like a continuous monitoring of data. Then system failures of IoT systems. Just assume that you deploy a lot of IoTs and like robots in the supply chain, which are continuously operating. If a single failure will occur, whole your factory or your company will go down. Then the most important is the battery constraint. You cannot deploy powerful computational capabilities due to limited batteries. Non-back communications, like you are not including any security features and these things with that. Then there will be a supply chain disruptions also due to like a lot of like attack pattern and whatever the things you have to supply. Just assume that the sensors, whatever you are developing, if you are using some robotic pattern or something, industry 4.0, and some kind of a supply chain attack happen on your company, you cannot produce the goods and these things. Track and trace problems. If you are not keeping the logs and traces in your systems, then it's very difficult to identify what was the problem. The last one is the network connectivity. This is because if you cannot define a secure network connectivity, there will be a major concern about these things and all. If you look into a holistic security viewpoint of particular applications like IoT and cyber physical systems, so it can be seen like that. You have a malicious users, malicious manufacturer, and external attackers. They use some kind of a threat sources, threat vulnerabilities, or some kind of a particular attacks like exploit some security issues or communications default features, authentication issues, or whatever the things available in the exploiting manner. They usually target that. Then what is the consequence with that? So they can enter through the back doors. They can also take the remote privileges access. They can also steal your devices. They can also deploy some fake applications. Okay, so these are the some security viewpoint for a particular IoT and cyber physical systems. So when we look into the basic like a risk and vulnerabilities, so why current solutions fail to protect? So these are the major three things. Like they have a limited visibilities, cannot identify previously unseen IoT devices. Just assume that in 2020 or 2021 in the COVID era, if a lot of IoT devices or companies release a lot of product, if they are not connected with the internet, we don't have a trace out for that. Okay, so they are deployed in the some companies and they are locally using for the lane and everything. So it will be very difficult for them to update and these things. So limited visibilities, no protections, like existing like a visibility centric solution do not offer native prevention or enforcement. We don't have such things, and very hard to implement in new solutions. Just assume that if I will develop a new solutions, if I want to deploy on the hardware level, it will be super difficult. That's why we always focus on the security by design solutions. So these are the some attack on the network levels. So let's look on the firmware levels also, because if your firmware will be compromised, so everything whatever in the system is going, it can be compromised. So you can also target on the firmware through some kind of a ransomware attack, trojans, rootkits, botnet, spyware, buffer overflow. These are the some kind of methods or mechanism which can be targeted to control your firmwares while doing the updation and these things. Then some kind of a particular attacks you can also perform on the communications, like jamming, the authentications, traffic analysis, eavesdropping, false data injections, or DOS attacks. Okay, so these are I don't want to go into the detailing of such attack, but these are the some methods and mechanism which target on the communications level of a particular devices. Like if you deploy some IoT, some cyber physical systems, and you have a connecting robot and drones and your doctor and everything. So if they are working in a coordinated environment through the communications, so but communication can be targeted with the following methods. So we have looked cyber physical systems, IoT, then some kind of a security issue, security flows, risk, threat, actors. We look only problems. Now what are the solutions? Where we look? So recently we developed a solutions like a lightweight misbehavior detections. So just assume that a particular device, which is a very low in computational environment, like a sensor or like a pacemaker in your body, or maybe like a patient control anesthesia, like that kind of devices. They don't have a very powerful computation capabilities, but you cannot check these devices are hacked or not. Okay, if they are controlled with the internet and these things. So we have developed a behavior rule-based solutions which can look into the particular device, continuously sense that device, and then we have identified that it's in the correct state or not. If you are interested, then you can look into this paper, IEEE transactions, like what we have developed. So what was the challenges? Challenges are the like there are a variant. There are not a single attack, like a multiple variants. Like someone is targeting like X, someone targeting Y parameter, someone targeting Z parameter. Parameter can be vary. So there are multiple variants of attack. Then always there will be new attacks because we don't know. Everyone is trying to finding a new vulnerabilities. Then recently we have also bypass analysis techniques, like a limitation of behavior like analysis someone can bypass. Then very like a limited solutions to identify the false or irregular behavior. There are the high false positive rates and high false negative rate, and risk of the system infection during the analysis is also high, because just assume that this is the like a COVID. When you test someone it's in the COVID like a symptoms or not. If you have a symptom, then it can also affect the everyone's also. So such a situations also came. So bypass virtual environment also, they can also some attack patterns can also do like that. And very difficult in real time processing. So when you want to process for the real time, it's super difficult for them. So we need a lot of resources, storage spaces, communications, and high computational power. So these certain challenges we have seen here, like you can see the multiple challenges with the particular known and unknown attacks on the targeting for the behavioral pattern. We have to identify a lightweight solution which can comply with that. So that's why we have developed a monitoring based misbehavior detection approach, which you can deploy into a two-way. Either you can deploy into the particular monitoring source code into the secure computational environment like a TPN and everything into a device. Either you can also look into another, you can deploy another device which is continuously looking, continuously sensing the nearby devices. So just assume that you have a manager which is continuously asking that are you correct or not. Okay, you have to, if you are correct, then you have to prove something. Okay, so whatever the things you have to do on the basis of we continuously comply the behavior compliances, and we can say that the device into the correct state or not. So let's take a case study like PCA, patient control anesthesia and medical cyber physical systems. So just assume that a PCA devices, IT device in a medical CPS is charged with the following operational profile. Operational profile means how they are operating, because your behavioral rules and everything will be operated on the particular operational profile. So it's like a raise an alert to designated personnel and halt anesthetic injection if the patient's medical condition is unfit. Raise an alert of designated personnel and halt anesthetic injection if the patient is not ready. Communicate with the authorized personnel only. Okay, so this is the particular like a particular operational profile for a PCA. On the basis of what we have done, we have developed a security requirement. What should we look like that? Okay, so security requirement like PC must raise alarms or whatever the things on the basis of operational profile. These security requirement leads to the threat identification. Just assume that a single security requirement have a multiple threads. Okay, just assume that if it will not go to particular alert, then what can happen? Okay, so PC is not able to raise alert and hold anesthesia injection when patient is unfit. PC is not able to raise alert. Okay, so these are some kind of a threat. Then threat leads to particular behavior rules. So what kind of things we can do, what kind of security aspect we can integrate particular behavior rules. So raise alert to designated personnel and hold anesthesia injection if just assume that a single requirement we have converted into a behavior rule. It should be fulfilled by the particular device. Then behavioral rules we have converted into a Boolean conditions. Okay, so mathematical conditions like a pulse rate is not equal to normal, and conditions actions is not equal to alert and hold. So we have converted an all behavioral rule into the attack behavior indicator. And these attack behavior indicator can be deployed as in the state machine form on the particular PCA level. Okay, so it's look like that. So this is your particular processor. So secure computational space can be behavior rule and monitor code, which continuously monitoring with your additional parameter of your hardware, drug, doses, timer, and everything. And it's also checking your device into correct state or not. So this is the approach, and we also tested with the drones and everything. So one of the another example with the like a semi-guided drones, this approach can be applied for that. And you can also you can also deploy some kind of a machine learning, but lightweight, like a tiny ML machine learning algorithms also, if you want to work with that, which is very less computational requirements, that can be also adapted with such a process. And now we are also recently completed a new project about the transit, like a transform safety critical cyber physical system into distributed solutions. So what happened, earlier we have a standalone systems, then we have distributed into the multiple stakeholders. Just assume that one person can be in India, one person can be in another country, and they are operating for a single like a cyber physical systems, so they can be distributed. To develop like a distributed solutions, we have a multiple challenges on each layer, like for the device level, for edge level, for cloud level. Okay, so our goal is to develop a universal applicable distributed solutions. The architectural concept we have developed a framework and transition methodology for the cyber physical systems. So you can look into, this is the architecture level. So just assume that your device low level, then there will be edge where you are sending the data, and there will be the cloud where the processing and everything can happen. So which is also considering like a safety critical function, non critical functions, then safety performance and security monitoring services. We have to deploy operational mode manager, then identity access services, remote update client, and these things. Okay, so what was the objective? We have we have developed some kind of edge and cloud technologies for the safety critical cyber physical systems, and we also ensure safety and timing performance from a user perspective, and guarantee a security and privacy for device aid cloud continuum. Okay, so this is the genuine applications. Let's see one of the example about the medical cyber physical systems. Like we have done the image guided therapy and diagnosis imaging systems. So just assume that whatever the things without a doctor perceptions and everything, on the basis of data, and we have done the diagnosis. So your image-based diagnosis, CT or MRI, pre-treatment planning, physician's office, multidisciplinary teams, and the IGT labs and classrooms. And guided treatment directly will be your particular therapy or your exam, yeah, directly cath labs where that will be performed. What is the current challenge? So need to go for operating room for planning, difficult to share information with the staff or peers, availability of latest clinical tools, all the locations, updates mean downtime of lab, difficult to add third-party tools, limitation in computational resources, and very high capex, like a computational cost. Capital cost is also to operate such a function is also difficult. These are the some certain challenges while working such a systems. Then what will be the value when we work with the solve such a challenges, like data accessible to anyone anywhere, seamless data for flow workflow for planning to live use, latest version of clinical tools, or that kind of, and distributed solutions, pay by values. Like if you pay some things services, then you can directly access these things. So these are the things we have targeted. So how the innovations work like that, from the device level, like a device tier, when you are operating some things. So safety critical real-time image and data acquisitions and viewing you can do from here. Then interventions, planning, offline reviewing, and cloud enhanced applications can be done as your remote servers. And then cloud tier can be third-party integrations and enhanced services. If you need, like just assume that you have done the scans and everything. If you want to process the scanning result with some kind of existing report or something, and you can also use the AI applications here for the particular processing and these things. So these every like a lot of applications fall under into this device as cloud continuum. So this is just assume that how it's architecture particularly map. So this is your imaging room where the images and everything will taken. This is the hospital IT, and the cloud will the storage like third party if you want to consult with the third party doctor and these things also. So what kind of recommendations we have learned from the previous slides? Always we have to include the securing by the designs. So when we go for the fundamental basic need of a particular like a particular device or particular like a cyber physical system, if we are designing or we are in the prototype, we have to focus from the design level also. Then we have enhanced policies. You have to up to date your policies, like a password policies, ID based access control policies, or how to operate the policies, how you will deal with the LLM models, chat GPTs, and these things in your systems. Then real-time isolations also. If you find a vulnerability issues, or if you have seen such a abnormal pattern in some particular segment, then that segment should be isolated. Enhanced testing phase, like in the testing you have to also focus on the verification and validation things also. Then application level testing you should also perform. Safer designs, that's go to the secure systems. Smarter designs, that's the requirement for the quantum, like a power systems and more powerful systems. Simpler designs are easy to maintain, like if they have a proper systematic segments, then it's quite easy to operate. It is easy to isolate and easy to cure the systems. A smart self-healing process, like if some functions are not working or some part of your whole setup is not working, then how they load and systems and how they can heal from each others and these things. Then human machine interactions, they should be also be more in efficient manner. Then These are the recommendations. Then we can also apply some kind of a frameworks. These are the standard which are helping to set up a secure systems. Like we can identify the issues, what are the like a cybersecurity risk, what are the asset, what are the datas. Then we can also develop some kind of implementation solutions, safeguards to ensure the critical systems. We can deploy some solutions. You can also, companies, mostly companies are using SIEM, cementing endpoint solutions. And some organizations like your water suppliers and your energy grids, they are using some kind of standard IEC 66432, and some kind of another standard which are focusing on the protections levels. Then you can also develop some detections levels like intrusion detection systems and some kind of monitoring systems which are developed and implement to appropriate activities to identify the occurrence of the cybersecurity events. Then you can respond if there is attack, what you have to do, how you have to isolate the systems, and how you can mitigate and the systems while the recovery. So this is the 5 phase. So cybersecurity framework is applying in every sectors, not only in the SCADAs and cyber physical systems and these things. From your root levels or small companies and small hospitals also, you can adopt such a framework to reduce the cybersecurity issues. And how you can improve the 360 security, like there are plenty of features. You can also focus about the network security, data security, infrastructure security, system security, application level security, mobile security. Then some kind of a risk governance and compliances like ISO 27001 for the banking application and these things, advanced threat protections and these things. So when you want to improve the overall security postures, these are the recommendations you have to look for the particular security enhancement and these things if you want to improve the overall security postures. And how you can maintain and achieve these security goals, like if you focus on the confidentialities and device integrity, data availability, strong devices authentication mechanism. You can also protect digital evidence, like you can collect the logs and everything. It's not like that if you are dealing with the, if you are working with the low like a code low devices like a drone, robotic, IoT devices, these things, you need a logs, because if a certain abnormal behavior or attack happen, how you will identify the cause of the attack and how you can recover that. Then enhance security policies, that's on the governments and policies. You can also adopt the compliances, some kind of a GDPR compliances and these things. Smart cooperations with the non-cryptographic solutions. Yeah, you don't have to go for like a very powerful. Then instead of, then you can go for token-based solutions and ID-based access. And then enforce compliances. We also discuss like a GDPR, cybersecurity, like a CSF. This kind of framework you can also apply. Then also trade-off between availability and safety, availability and security, and safety and security. Because when you deploy a security, definitely the performance is a challenge. Okay, just assume that whenever you enter into a room, I continuously check after every hour, I will check your ID card. It will be a burden for you because you are paying attention to do some work, then suddenly a request came like you have to show your ID card. So similarly, when you entered into a network and someone is asking to show your credentials and you have to prove yourself as a genuine user, then it will be a burden for the normal users also. So we have to always maintain the trade-off between these performance and availability and securities, and these are the major research areas. So what kind of major barrier we have identified? Mostly on complexities, systems are complex. Okay, so we need a more trustworthiness of CPS, insufficient dependability technology to avoid propagations or fault attacks. Then multi-paradigm, so lack of established, because we don't have standardized bodies of these things. So how we can switch from one single standalone systems to multi-parties and these things. Then competence, education barriers. We don't have a competence like how we can transfer the knowledge from one systems to another, certifications of technologies and these things. Okay, so still also a issue in the inside the country wise, zone wise, and nation wise. Then some kind of a research and development needs, like we have to focus on the development of high confidence cyber physical system requirement. Okay, so where more engineering oriented design and techniques can be placed, where we have to focus on the more system software and network support paradigms. We also focus on the validation and certifications. So if a single certifications technique can be used, so which can be also adopt the same technology in the another manners. So these are some kind of societal challenges we are dealing with. There are plenty of application sectors, and we are dealing with the safety control, verification, and core science technologies, engineering, and these things. So we have to focus into a trustworthy, reliable, secure, privacy preserving, and usable, like these systems which can be like where you can blindly believe that your system is correct and it will not do any issue with your human life. So these are some final scientific challenges you can take away with you, like a computational and abstractions. You can focus on that. You can also focus on the composabilities also. Then system and network support, like what are the CPS architecture, virtualizations, wireless and smart network sensors. Then new foundations like a distributed systems. I already show you one of the example about the Transact, dealing with the uncertainty and adaptabilities like machine learning solutions, and a lot of AI driven solutions are coming. Scalability, reliability, robustness, and stability of the systems, and the science of certifications like evidence-based certifications and verification, validation, and testing. These things, if you focus for your research, these are the new themes which are focusing in terms of scientific challenges. And most important is distributed management of cyber physical system is hot topic recently. A lot of research organizations are working because everything is on the distributed. When there is a distributed systems came, it bring a lot of challenges, not from the performance wise, from the safety, from the security, from the coordination, from the synchronizations, from every aspect. It bring a lot of challenges, and real time monitoring, handling, adaptations. There are plenty of open areas where you can look into the research perspectives. So these are the final emerging themes like communication technologies, computing technologies, sensors, security of distributed cloud computing and communications, and system and control theories. Okay, so these are the some general themes where we can look. So this is the final roadmap. In like this is inner circle is about the like a 2022. Like when you talk about the mature, like this is the 2022 2020, like a for the engineering, automobile, and data analytics and architecture level. What are the key themes are going for the cyber physical systems? And the middle loop is mature by 2030, and this is the outer loop is more on the after the 2030 applications. Like in 2030 we are targeting about wearables, computer visions, virtual reality, augmented realities, and these things. If you talk about the safety and security, like a blockchain, which is the topmost, ethics by the design, safety and security by designs in systems with human and loops. Okay, so when we talk about the beyond 2030, like on the fly certification techniques, because over the air update, these are the challenges: trustworthy CPS with safety, security, ethics by design, trustworthiness CPS with human in the loop. So these are the like upcoming requirement. These are the upcoming research domains and requirement for the 2030, like that's era. So you can also pick up some topics if you are interested. You can read about that. So in each sector, it's not about only about the safety and security. HMIs, communication computing platforms, architecture level, engineering level, and autonomous robotics. So what we can conclude that attacks are growing. If you talk about the cyber physical systems and IoT, we have a motivations about the knowledge, resources, and persistence to launch attack, because machine learning is not only using to protect the attack, it can also use to proceed the attacks. You can use some machine learning algorithm to perform such attacks. So that can also damage the physical world, even the humans. So definitely we have to invest into security also. We need to be prepared to prevent, detect, mitigate, and respond to these attacks. So if you are working in any of phase, like if you are working as an engineer, if you're working as a educator, if you're working in a R&D sector, so when you are designing some systems, you always focus on these 4 parameters. And privacy is also issue as a governing concern, because in the medical sector, especially in your sector, like we need to design mechanism to facilitate the IoT systems or some kind of cyber system. If you are working with the health data records, we have to follow the compliances like GDPR and these things. GDPR is mostly on the European level, but and then, as the IT from the India also, they are focusing on the data records and data privacy also. Then there are some kind of a political and policy aspect also, because now geopolitics and like a nationwide politics continuously changing. So insensitive for securing ITs and new international legal framework for cyber conflict is also affecting due to changing of world politics and these things also. So the concluding manner is that CPS is the basic demand. They are growing very fast. In the 10 year, we are on the top notch quality productions and everything. Now we are moving to the autonomous industry. So security is the top flavor for the such a paradigm. If you want to contribute into security on in each like a each part of whole setup, like from the device level, from the edge level, from the cloud level, from the like a communications level. So everything whatever you are deciding, so if you follow such a security requirement at each level, so you can also deploy some particular solutions, you can design, you can update, you can optimize also. So that's all for today's talk. I think so we are on the time. Thank you. If you have a questions, I'm open to take some questions.
So thank you, Dr. Gaurav. So is there any query from the participant? You may ask in the chat box. As to all participants, if you have any doubt, you may ask in the chat box. Or you may raise your hand and the host will give you the right to unmute you.
Or if you have any interest to collaborate, and if you want to work for the any open problem in the cyber physical systems and IoT, you are feel free to reach me through email. Then we can have a meeting, whatever you want.
Sir, what will be the comfortable mode to communicate with you, either mail or via phone?
Mail, email, because the timing zones are quite different here, and I usually have in the meetings and like a research meetings, and so it will be a better thing to contact through email. Then we can have a joint meeting timelines also.
Oh, okay. So can you give your email ID on this chat box also, so that each and every participant will be able to communicate with you? If you okay, thank you, sir. So to all participants, is there any doubt or any query regarding the this presentation? Okay, so I think there is no query from the participant side. So if we get any query from the participants, we will connect with you via mail and will forward you and will ask you regarding the same. Okay, so thank you so much, Dr. Gaurav, for such a wonderful talk on the cyber security and how to secure, how to work with the industry 4.0, 5.0, and so on. So how to mitigate the risk and so on. So once again, thank you on the behalf of all the organizing team of this blockchain and AI health in healthcare FDP. So thank you, sir.
Yeah, thank you so much for inviting me in the panel. Thank you. Thank
It's
you
a great
for
pleasure
the.
for us to be here with for the session. So I was along. I was there during this entire presentation, and that was quite interesting for me. Yeah, yeah,
So you're most welcome to serve for further collaborations also. So
yeah.
always, whenever you need
Yes,
any
sure,
support,
surely
yeah.
I'll connect you regarding the same. Yeah, yeah,
Yeah, sure, sir.
yeah. Thank you.
Okay, guys, bye. Thank you.
Okay, so to all participants, the next session will start at sharp 4 p.m. So it's a 12 minutes break. Okay, so we'll connect again at 4 p.m. So thank you.
Hello. The next session will start at 4, so we will meet here.
application